focus of us, primarily those three types of graphs. And now what we're going to do today is we are going to look at ways to mislead a reader, techniques that can be used and definitely are used to sort of not necessarily lie. I don't know if I'd go that far, but you have a perspective and you want that perspective to be the one that the reader takes away from the picture. And there are certain things you can do with a graph or a chart that can sort of lead the reader to the conclusion you want them to draw. So that's kind of what we're going to be talking about today. All right. Here's a graph of teacher salaries. And what we can see here is we have a line graph because this is change over time. So we have our years on the x-axis. We have our salary data here on the y-axis. And as we look at these numbers, we can kind of see, well, in 1990, the teachers made about 30,000. 2000, they made about 32. And in 2010, they made 38. And as you look at this graph, you might look at it and think, wow, salaries have been flat for a long time. Like, you know, if you were a teacher in this district and you presented this chart, this graph, people would look at it and go, boy, salaries have barely even gone up at all over the last 20 years. These folks need a raise. With that in mind, the school district might have a different perspective on that. They might not want to give this raise away. And so that was pretty funny though. So what might happen there then is the school district would present this graph. And you look at that graph and you go, holy cow, there's an increase here and then a dramatic increase there. Salaries have gone up a lot. So I don't think these teachers really need a raise. What's really important to note here is the numbers in this graph, 30,000, 32, 38, compared to the numbers in this graph, 30,000, 32,000, 38,000. They're the exact same numbers. Those two graphs have the exact same data on them. The difference is here in the in the y-axis. You'll notice in the graph that the school board put forth, our y-axis goes from 30,000 to 38,000. In the graph put forward by the teachers union, our y-axis goes from 0 to 38,000. It's the exact same data. The picture is wildly different, and the reason is on this graph, we have zoomed in on the data. Essentially, what's happened is this piece of the graph right here is all that's being shown in this picture. And zooming in like that, what it's called is you're cutting off some of the axis. Instead of using the entire y-axis, the graph from the school board only shows this much. They've cut the rest of this off. And when you cut that off, what that's called is truncating. If you truncate the axis, you are zooming in on where the data is located. And when you zoom in on where the data is located, the result is that the changes look more dramatic. They look more significant, more dramatic, bigger. Like the changes in the salaries, well, gosh, it went up here and then holy cow, look at that. It's a huge increase. And it's because we've zoomed in. The data is exactly the same. If you instead show the entire y-axis, you have zoomed out, this is going to make your changes look less dramatic. Again, neither side is lying here. They're giving the real data. These are the numbers. It's just the way that it's presented can lead you to a certain conclusion. This graph here looks like, wow, salaries are pretty flat. They deserve to get a bump. This graph here was like, I mean, we've been given them raises. Look at this. Look at the increase. and it's the exact same numbers. A couple of things. I want you to be aware of this just as a consumer of different graphs and different data. I also want you to make sure that this is the kind of thing you share with your students when you're teaching them, that be an informed consumer and don't just immediately look at this graph and go, wow, huge change. Yeah, but they've drawn this in a way to make you think that. Now, your position on whether or not the teacher should or shouldn't get a raise, taxes should go up or taxes shouldn't go up to fund that raise, that might depend on your personal situation. But the data being presented this way and the data being presented this way give a very different picture of what's happening, even though the data is exactly the same. Type of question you might see from me is make sure that you know that zooming out makes a change look less dramatic, and zooming in, which is another word for truncating, makes the change look more dramatic. That's the kind of thing I'm going to want to make sure that you know about this type of information. This technique works great on a line graph, but it can also be done on a bar graph, as we see here. Trucks sold in the last 10 years that are still on the road. So we want to tell you how reliable our trucks are. Well, if you work for Chevy, you're going to make sure to use this graph over here that is, you'll notice, zoomed in. In that picture, our y-axis doesn't show the whole thing down to 0. Instead, it cuts off some of it. We have truncated the y-axis to only show a part of it. And if you look at that, you're thinking, wow, I definitely want to buy a Chevy because look how much higher their bar is than all the others. Same exact data. If you work for Nissan, you want to show this chart over here. You want to zoom out. You want to show the entire y-axis, because then, I mean, if you look at these numbers, they're what, 96, or excuse me, 98 and a half, 97 and a half, 96 and a half, 95 and a half. In real numbers, if we go from 0 to 100, they're pretty much all the same. But this picture makes it look like they're wildly different. This picture over here makes it look like they're pretty much all the same. Again, when we zoom in or truncate, the changes look more dramatic. If we zoom out and show the entire y-axis, the changes look less dramatic. And that can be done on a line graph, or it can be done on a bar graph. Let me know if you have any questions about that. The idea of truncating, which is zooming in, those two words mean the same exact thing as each other. If we say truncate or zoom in, that means the same thing. And zooming out will make it look less dramatic. Okay, very good. Another thing you can do is use an inconsistent scale. Here we have state and local property taxes, and if you're the municipality where this is the case, you might be going, look, our taxes have been flat for a long time. We're probably due for an increase. I mean, you know, they went up a lot. Actually, they went up a lot, but then, you know, they've leveled off and been flat for a long time. So I think we're due for an increase. But if you look carefully at this, what you'll see over here in our y-axis, and here again, we're playing with the y-axis, is, well, one thing that's odd about this is the y-axis is our time. So we can't really read this left to right. Ideally, you're going to have time on the x-axis so you can read this left to right, just like you would read a book. You read it left to right and you can see what's happening, but this is a very strange choice to put the y-axis, put the years in the y-axis. So that's something that's odd about this one. And the reason I mention these things with the truncating and looking at the y-axis here is your homework's going to ask you for, what do you see here as far as this picture goes? Is it reliable? Is it valid? Which we'll talk about in a little bit, but also, critique the graph. Well, have they done anything funny here? When I say inconsistent scale, what am I talking about there on that y-axis? What do you see that makes that scale inconsistent? And there are a couple things you might notice. I figure I'll just give you a chance to throw some out there. Very good, Edison. Zara, that's perfect. Yes, Carolina, you're all exactly right. So if we look at this, what we see is there's a 2-year gap, and then a 2-year gap, and then a 2-year gap, and then a 4-year gap, and then a 4-year gap, and then we have this 6-year gap, and then we're back down to a 2-year gap, and now we're blending 2 years together in those, like it's all over the place. And what y'all said is exactly right. If you're going to make a graph, and this one, the other two where we were looking at the teacher salaries, those are both fair. They change the y-axis to sort of give their side of the argument, but at least what they did was fair. This isn't even fair. They have totally manipulated the y-axis and used an inconsistent scale. So this graph is just junk, and we can't make heads or tails out of this. So hopefully they would get criticized for that and have to make one that, even if you put time on the y-axis, which is odd, you would use a consistent number of years between each one of your marks over here. Something else you can do, more common in a bar graph, is use a distorted image. We know how a bar graph works. We have categories down here on the axis, and these are years, but this isn't really, you could certainly do a line graph here. It is change over time. Line graph would probably be a better choice. But then if you wanted to say, okay, here's my 2010, here's my 2020, and here's my prices, it doesn't tell me what the prices are. That'd be a little bit helpful, but at any rate, the problem here is, yes, it's true that this bar is lower in height than this bar, but the width of this bar makes it look way bigger than the other one. If these two were the same width, if this one had the same width as the other, we'd see, okay, this one and this one, yeah, there's a difference there. It went up. But instead of doing that, what the person who made this graph did was make these really wide to make it take up so much more space on the page that visually it's like, whoa, that's way more. And so using a distorted image like this is a way to make a misleading graph to kind of convince the reader of something that most likely isn't true. Otherwise, you wouldn't have to use the distorted image. Another thing that can be done is cherry picking data. Here we're looking at the stock price for Amazon over time. It's a line graph, so change over time makes sense to use a line graph. So we have change over time. And if you look at this graph on the top, what would your thought be about Amazon stock? What's happening? And there's, it's what's happening to the stock up here. What does it look like in that image? Excellent, Edison. Yeah, Nicole, it's decreasing. Stephanie, perfect. Sorry. Yes, it looks like it's going down. If you look at this picture, you're like, man, I don't think I want to buy this stock because, if you look at the general trend here, it's not great. I don't think so. course, if you look a little bit more closely, you can see that this is March 8th, March 15th, March 22nd, March 29th. What's happened there is we're only looking at 1 month of data. And in that 1 month, there is this general trend of it going down. In contrast to that, if we were to back up a little bit, and we back up a little bit, and we look at a 5-year window, now our general overall trend is, oh, it's going up. So our general overall trend is going up. Maybe I do want to buy this stock. This is just sort of a temporary little blip here where it's down. Over the long haul, this stock's going up and I do want to buy it. And this is what's meant by cherry picking data. We've cherry picked the data to see, well, if we just look at this 1 month, yeah, it doesn't look so good. But if you take a step back and look at the 5-year window, we're seeing something different. What else happened with the first graph, the 1 month graph? What's going on in there? What's something else that's going on in there to sort of manipulate your perception in the 1 month graph? And there is something I'm kind of looking for here. The amount of time, yeah, it's definitely short. It's only a month. You're right about that. We're going from like February 28th to March 29th. Anybody notice something else that manipulates our thought process there, that that looks different in this picture than it does in this picture? Because we are only talking about a month, so we're just talking about this little bitty slice right here. Other than cherry picking that 1 month, what else is going on? What about the y-axis, Karina? What's happened over there? It starts off at a higher number. It's only going by 50s instead of 500s. These are all true. There's one really big word that I want y'all to tell me. Somebody tell me that word. Everything you've said is correct. There's one word that I really want you to say that's happened over here in this y-axis compared to this y-axis. What's happened to this one? All right, Edison, very good. That's the word I was after. Very good. We can see that this axis up here has been truncated. We have zoomed in. Because you'll notice this goes from 2000 all the way down to 0. So even if we were just to look at that 1 month, it doesn't look that bad. But if we look at that 1 month and we truncate the axis and zoom in on it, now it doesn't look so great for that stock. That's very good, Edison. Yeah, I heard a good piece of advice from Vanguard as an investment company. The guy who started it was Jack Bogle, and he said that every month you're going to get a statement in the mail. Don't look at it. Basically, the idea is if you try to pay attention to the stock market or your retirement or even how much you're getting in a savings account every single day, it'll drive you crazy because there are fluctuations. Things go up and down. If you just take a step back and realize that even in a savings account or certainly investing for retirement, it's a long-term prospect. And so you need to think about it in the long term. That was kind of what he was getting at with the don't look at your statement, because it'll cause you to panic and do things that may not be the best thing for you in the long run. But I agree with you. I tend to go oh, what happened this week? Oh no, instead of just calm down and let the long term run its course. Okay, so two things on this page: cherry picking data, just using this 1 month instead of looking at the big picture. And we can see that the axis has been truncated, making the change look more dramatic, as opposed to being zoomed out where the change looks less dramatic. All right, let's talk about reliability and validity. And I'm not going to ask you to recite these definitions to me, but I do want you to be aware of them. Reliability and validity are two concerns. Anytime we're dealing with data, we want to know, is it reliable? Is it valid? Those are two questions that we always want to sort of keep in the back of our mind. Where did this data come from? And is it reliable? Is it valid? Reliability is about the consistency of the data. And what that means is, if I were to do this same poll, sample, whatever it might be, again, would I get similar results? If I went out to a creek and captured some water and tried to see how much bacteria was in that water, if I went out a week later and did the exact same thing, would I get similar results? They don't have to be exactly the same. And obviously, if there's a huge rainstorm in between, that might throw things off a bit. But the idea here is, would I get similar data if I did this thing over again? It's, we're already in an election year. There's going to be lots of polling taking place, and they want their polls to be reliable. So, if you take a poll in February and then you take it again in March, can you expect similar results? Now, obviously, there are factors that go into that, but the idea is, if you ask people, do they prefer Coke or Pepsi? And then would you get similar results a month from now or a week from now? If you did the similar action, would you get similar results? If so, then your data is reliable because it happens over and over every time. Validity is about the accuracy of the data. And what that means is, did what we do measure what it was supposed to measure? Were we doing the right thing for this particular question? And what that's about is, if you do an unbiased, random sample, that's how you can make valid conclusions. That's how your data is accurate, and we would say that it's valid if it's an unbiased, random sample. Although, if you have a biased sample, then those aren't going to be representative of the opinions of the entire population. Here's an example of that. Here's what I mean by that. Well, I just want to reiterate, reliability is it consistent? Will we get the same results over and over again, or similar results over and over again? And then validity is about how accurate is it? Did I do an unbiased random sample or not? And if it's biased, then my data is not valid. And so I can't really make any conclusions because my data is no good. And here's an example of that. I'll ask you this one in a poll, even though I don't think it's a hard question to answer. A new landfill is going to be built near a town. A survey is conducted by interviewing the 100 residents that live closest to the proposed location of the landfill, and it's found that 90% of them are opposed to the new landfill. Does this mean that 90% of the town is opposed to the landfill? I'm going to make a poll for this one. And as we read through there, so we're going to make a landfill. Here's where it's going to go. How many of you want it? Let's do a survey. And we do a survey, and we ask the 100 people that live closest to where the landfill is going to go. Essentially, what we're asking here is this data valid, is what we're trying to find out. Does this accurately represent the feelings of the whole town? We'll go another, I don't know, 15 seconds, maybe 30 on this one. And basically the idea, really what this is saying is, was this survey valid? You know, all right, let's go ahead and take a look at our results of this one. See what we've got. Pretty strong on the nose, not unanimous, but pretty strong on the nose. All right, so let's take a look at this. The people that were surveyed here were the people that live closest to the proposed location of the landfill. Nicole says it's not even close to valid. We don't know how many people live in the town. That is correct. You're right. This could, maybe there's 1 million people in the town and they only surveyed 100, which would be a teeny tiny little fraction. We'll talk about margin of error for polling in chapter 3, but that's an excellent point you make, Zara. My question to you is this. Okay, they're going to build a landfill, and what would be a proper way to survey people? You don't want to ask the 100 that live closest to the landfill. I tend to agree with you on that. Sometimes questions of reliability and validity are not completely black and white, but this one, I think, asking the people who live right next to where the landfill is going to be built, probably not a random, unbiased sample. So what would be a good way? And this one, it might take a lot of typing. Okay, get a sample size that's as random as possible around the area. That's an excellent answer, Natalie. I like that very much. There are a couple ways you can do this. If it was if it was the 1980s or maybe even the 1990s, you could use the phone book and go through there and just randomly pick names. That would be a random sample. Unfortunately, many of you might not know what the phone book is, and we don't have those anymore. But another way you could go about it is looking at your property ownership on the county records. If you wanted to take a sample from that, you'd have all the residents of your county listed in one place, and then you could use a random number generator or something like that to sort of, you've got, I don't know, let's say 15,000 people in the town, they all get a number, random number generator comes up with 100, 200, 500, however many you want to survey, and those ones are picked at random. Some of them will probably live close to the landfill area. Some of them will probably not, because you're doing this at random. But that is a key here, is we want a random, unbiased sample. I think the problem with this one is the bias part. If you live close to where the landfill is going to get built, you're probably not that interested in having it there. Let me try another one with you. If we wanted to know the favorite restaurant of CSN students, would a survey of students at the Henderson campus provide valid results? Again, I'm going to do a poll for this one too. This is the kind of thing I think local businesses would love to know. What's the favorite restaurant of students at CSN? And so we could go take a clipboard and walk around and ask people questions, maybe give them a list of, I don't know, half dozen or a dozen different choices, but maybe not. Maybe leave it wide open for them to say whatever it is that they want to say. Let's go, I don't know, another 30 seconds on this, and then we'll talk about it. And I will say, like I mentioned earlier, questions of unbiased can be a little bit gray sometimes. They're not always black and white. And so if you disagree with the herd on this one, it's okay, and you can make your case if you want to. We'll hear it. I'll make a case for what I think is correct here and justify that answer. But you know, I'm open to hearing a different point of view. I do think when you get into serious statistical studies, you definitely want to make sure that your sample is unbiased and random, rather than anything that might invalidate or compromise the results that you come up with. All right, let's see where we are on this one. Pretty much the same kind of ratio there. Pretty much everybody's saying no on this one. And I would tend to agree with that because, well, the first thing that comes to my mind is if we're only doing this survey at Henderson, there could be restaurants in Henderson that students pick as their favorite that they don't even have that restaurant near Cheyenne or North Las Vegas. So it's you could get a very skewed result here by students picking something like that. What would be a different way to do this? What would be if you were going to try to find out? Right, it's a different population at Henderson. It's a different group of students. I agree completely, Zara. You're exactly right. So if you wanted to find out what the favorite restaurant of CSM students was, what might you do? And there's not necessarily a right answer here. I'm just curious to hear what you'd come up with, keeping in mind that what we're after here is an unbiased, random sample. What would be a good way to do that? And let's say you don't have access to, you know, the registrar's office, although that's not bad either. You could ask the registrar's office for a list of all the students, you know, survey random students at each campus. I like that very much, Stephanie. And how would you identify random students? What would be a good way to do that? And you don't have to overthink this. Ask every English class at all 3 locations. I think that's pretty good, Escadar. And that's a decent choice because pretty much everybody has to take English, right? You know, you wouldn't want to necessarily go into a science lab and ask those students because you've kind of change it. Student union, I think, is excellent, Zara. That was the first one that occurred to me. And Stephanie, just students that are walking around campus. That's not bad either, because that's definitely random. I think those are excellent choices. All of those are excellent. Something like a science lab I might not do, because students who are taking a lab science might not be representative of the wider campus at large. An optional survey through email. That's an excellent point, Natalie. I like that one too. And there's one of those things where, what is it called? The rate of response and response bias. You know, you might find that students that are over 40 are more likely to respond, and students under 40 are more likely to go, nah, delete. You know, but I think that's an excellent idea of getting a random sample. We send it to everybody, and we'll see what we get back. I think that's a good choice too. The key here is what we don't want to do whenever we're conducting some sort of experiment is box ourselves into something that we know is not going to be random right away. Because if it's not random, then it's not going to be valid. Very good. Okay. Section 7.1 doesn't have a ton in it. I have to be honest with you. This is a pretty light week for us, but there is one other thing that I wanted to bring up. Anytime you've got a question about reliability and validity, and that'll be part B in your homework, it'll come up as, in 15B, 17B, where it says, discuss any issues of reliability and validity you might have about this data. And there's not really a right or wrong way to answer that. There's a lot of right ways you can. And the key here is, I just want you thinking about these things. Is it repeatable? Is it an unbiased random sample? Where did the data come from? In addition to thinking, is this graph presented in a way that's trying to get me to think one thing or the other? I also want you to be aware of, is this repeatable and is it valid? Just sort of as a general consumer of graphs. Okay, the one last thing I wanted to talk about in section 7.1, and this will finish off our week, really. This isn't a very busy week for us, so it's a perfect time for you to do that ProctorU extra credit quiz. As we get deeper into chapter 7, we'll be doing a lot more number crunching. This week is a pretty light one, and hopefully that's good news for everybody. You can mislead with graphs. We've kind of seen that. You can also mislead by which data you report. What I mean by that is this. There are measures of central tendency that can be calculated for any data set. It's going to be a big part of our week next week when we get into section 7.2, are those measures of central tendency that are called the mean, median, and the mode. And like I said, we're going to be calculating those things next week. So right now, we're not really talking about calculating those. This is just sort of to set us up to head that direction. When you're describing a set of data, any of those numbers can be used. Oh, good. Very good, Nicole. So when you're calculating, after you've calculated mean, median, and mode for a data set, you can use any one of those to describe the data set. For example, for a fire department in a small town, the mean salary of the employees is $50,000. The median salary is $46,000, and the mode salary is $40,000. If salary negotiations were ongoing, which of those numbers would the employees use in their communication with the public? I'll make a poll for this one. I don't think it's a hard question, but it is going to come up this week on your quiz. So I want to make sure you're just aware of this type of question. We're not calculating mean, median, and mode yet. We're just talking about how you might try to influence using mean, median, and mode. So if you were the employees, which one of these would you use? Keeping in mind that you can use any one of them. And don't overthink this. The obvious choice is the right choice. Same thing's going to be true if you see a question like this on a quiz. The obvious choice is the right choice. And the assumption we're making here, and maybe you didn't when you read the question, the assumption that we're making, and I probably should have made this more clear, is, salary negotiations are ongoing. They want to get a raise. So, they're trying to get public opinion on their side. They're trying to get the public to support them. So we'll go another 15 seconds on this and then talk about it. Okay, let's see what we've got for results here. Okay, interesting. Most people said the median. Okay. I didn't do a great job on this one. Essentially, what we're after here is this. Any one of those numbers is okay to be used. Some of you may have some knowledge about measures of central tendency and might have brought that to the table here. pretend you don't know anything about measures of central tendency. And these are the three numbers that the employees could possibly use when they're standing up at the podium talking to the press about why they need a raise. If you're going to argue that you need a raise, you're going to want to use the smallest possible number because that's going to give you the most sympathy. Yes, Edison, I agree with you here. And so they'd use the mode, and they would go up to the podium and say, the mode salary for our firefighters here is $40,000 a year. Nobody can live on that. We're going to need a raise. And so that was what I was trying to get at with this question. And I don't think that I did a very good job of setting that question up. But in the same way that those graphs we were looking at early on, if you're the teachers, you want to use this graph to say, our salaries have been flat forever. If you're the school district, you want to say, look at these raises they've been getting. So you want to present the data in a way that is favorable to your side. And that's what I was going for with this one. They're in a salary negotiation. So when they talk to the public, they want the public to think that they make the smallest amount of money possible. So they would use the mode in that case. And I hope that makes sense. If it doesn't, please let me know. It sounds like we fixed it up for Carolina, which is great. But that's what I was going for with that question. If you see something similar to that on the quiz, don't overthink it. If you're salary negotiations and you're the employees, you want to use the smallest possible number. If you were the fire department or the city council or the mayor would say, well, mean salary in this department is $50,000. They don't need a raise. So depending on which side you're on, you're going to either share the smallest possible number with the public if you're the employees looking for a raise, or the highest possible number if you're the city council trying not to give them a raise. I hope that makes sense. And if it doesn't, you can feel free to ask me about it to make sure that's clear before we wrap up and you start working towards taking that quiz.